Good morning, everybody. My name is Phuc. I'm the professor of the University of Information Technology, Vietnam National University, Ho Chi Minh City. Today I will present chapter 2. Welcome to chapter 2. Okay, in this chapter, I will help you to understand the relationship of information system development and database development. I will describe the goals of database development. Okay, how you to grab the step of the database development process. And I will help you to explore the case tool to support you in database development. I will go to the outline of this chapter. The first one I will discuss with you about the context for database development. I will show you about information system development, about the graphical model. You know the goals of database development is very broad, but we will show you some guidelines of design result. And what the phase of database development? You have many phases. You will study about the waterfall model, and you see the inputs and the outputs of each phase. And the last one is the case tool. You see here is an information system. You see an information system. The system will accept the data from its environment and process the data and produce the output data for decision making. The information system will interact with environment. And you see the database. Database is a long-term memory storage as can keep your data long-term memory. But you remember database is not a unique component of an information system. In information system, maybe you have inputs, the outputs, the processing, the software, the hardware, and the people who use the system. And in this example, you see a student loan system. We will discuss this system in detail in chapter 30. Now let me go to traditional life cycle. In this figure, you see the phase of traditional system development life cycle. The particular phase of the life cycle are not standard. Different others and organizations have proposed from 3 to 20 phases. The traditional life cycle is often known as the waterfall model or methodologies because the result of each phase flow to the next phase. This is the input and the output. The traditional life cycle is mostly a reference framework. For most systems, the boundary between phases is not clear, and there is a considerable backtracking between phases. But the traditional life cycle is still useful because it describes the kind of activity and shows addition of detail until an operational system emerges. Now I go to development alternativity. I have some difficulties. The first one is the user does not know, so serve of a large number of requirements. Remember, the requirement changes are natural or given user involving knowledge. And you can use the prototype to make system more concrete to a user. Of course, you must have experience in the system development. And you can use prototype can help you clarify on parts of a design. Remember, we have many methodology. The first one is spiral. The life cycle phases are performed for subset of a system, progressively producing a large system until the complete system emerges. For rapid application development, delay producing design documents until requirements are clear. Scaled down version of a system known as a prototype are used to clarify requirements. Graphical model. You see explicit or implicit derived from a prototype with defined behavior. A process model, you know about the relationship among processing, input, output. And in this book, you learn about the data flow diagram. Environment interaction model. Dynamic interaction. What triggers a process, user behavior or environment, a micro level model, user interaction with forms, or macro level model, workflow. About data model, you will study about entity and relationship diagram. And even though model of data, processing, and environment interaction are necessary to develop an information system, in this book, we will emphasize data models only. In many information system development efforts, the data model is the most important. And for business information system, the process and environment interaction models are usually produced after the data model. Rather than present notation for the process and environment interaction models, this book will emphasize prototype to depict the database system. Broad goals of database development. Development, you see a common vocabulary. You can define data meaning. You can ensure data quality. You can provide efficient implementation. Now, develop a common vocabulary. You define a data meaning, business rule, how an organization operates, how restrict should rule be, to restrict reject valid business interaction, to lose allow erroneous business transaction, rule of exception area between clear, cut, correct, and error. Example, faculty advisement to proxy, timing issue, prerequisite check, allow prerequisite to be violated, or data quality, many measure. How to measure the data quality? Remember, poor data quality leads to poor decision making, or difficult customer communication, maybe lost sales, more time with complaints, poor sales forecast, inventory problem, and so forth. We have a lot of things to do. Define meaning of data. Business rules support organization policy. Faculty assignment to cost, for example, timing issue, or prerequisite check, allow prerequisite to be violated, or maybe efficient implementation. Trump other words, no system if not efficient enough. Complex subject focus on advanced database score. And DBMS specific, we see a lot of things about the meaning of data. Sometimes data is ambiguity, ambiguity. Now I go to data quality. Poor data quality leads to poor decision making and very difficult customer communication. When you communicate with customer, it's very difficult for you to understand about the data. And cost benefit trade-off to achieve design level of data quality and long-term effect of poor data quality. Data quality measure. The first one is completeness. Database represent all important parts of an information system, so the data must be complete. Lack of ambiguity, as I discussed before, each part of the database must have only one meaning. About the timelines, business changes are posted to a database without excessive delays, not delay, but be on time. Correctness means database contain value perceived by the user. Consistency, different parts of a database do not conflict, but be the same. And reliability, failures or interference do not corrupt database. Importance of measure depend on the database, system and organization, and each measure can be quantified. Efficient implementation. You see here, services other goals, optimization problem, maximize performance, subject to constraint of data quality, determining and resource using. And difficult problem, number of choices. You have a number of choices. And the relationship among choices. Maybe trumps other goals. No system if not efficient enough. And complex subject focus on advanced database. Now let me go to database development phase. You see you have many phases. The first one is a conceptual data modeling, then logical database design, then distributed database design, then physical database design. And the input for the first layer, the top is the data requirement, and the output in the lowest layer is internal scheme populated database. Now let me go to the input. You see data requirement come in many formats. And you see the data will describe, you see about the data needs. And the phase here, you see the logical information content, conceptual data modeling, and logical database design. Now I go to conceptual data modeling. Information content of the database is the content of the database. You can study about the entity relationship diagram, ERD, showing entity types and the relationship among or between them. Historically, DBMS did not support many constraints and diverse format for database requirement. And later in this course, you can study about the ERD in chapter 5. And data modeling will be covered in chapter 6. I go to logical database design, refine conceptual design, convert ERD to table design in order to implement in the DBMS. We will analyze design for excessive redundancy. Normalization tool to reason about redundancy, how to reduce redundancy. And on constraints to enforce business rule. Now I go to distributed database design. Database design means the location of data and processing. It means the client-server processing, the parallel database architectures, and distributed database processing. The database will be kept not only one side, but the database will be kept in many sides. Performance orientation, not information. Content orientation, allocate success of database to different sides. Replicate subset of database to improve ability. Physical database design, perform FX, independent database size, minimize response time without consuming excessive resources. Trade-offs versus data update, flexible design versus specialized design, decision index database management. Okay, now I go to splitting conceptual design. You see in the slide about the conceptual data modeling. Then you go to data requirement. Then you go to the box view design. The output you will view ERD. And then you go to the view integration and entity relationship diagram. You see, if you have a large project, you can divide the large project work into smaller units and assign each work smaller one to team members. In view design ERD for a subset of requirement. And view integration in main, you combine small ERD into a large ERD. In chapter 12 of this course, we will discuss more detail about this concept. Now I go to projecting requirement. From system requirement, you have in the left hand is a data representation or data requirement. In the right hand is application requirement. You do two things together concurrently. About database development, you will use ERD to describe the concept of the database, and you will convert ERD to table design. And in the application requirement, you have application development. You develop process, model, interaction, model, and prototype. And then output from database development will be the operational database, and output from application development will be operational application. And you can combine two things together, operational database and operational application, in order you have an operational system. Now let me go to the skill technique for designing a database. You should have a soft skill and hard skill. In soft skill for information content, you have a qualitative, search for feasible alternative. You have interpretation of rules can be substantive, degree of subjectivity, or people-oriented. In hard skill for performance orientation, about optimization problem, objective function and constraint, about the data analysis, causal of problems. Most solutions are heuristic rather than directly from mathematical models, and modeling discipline are useful operation management. Data design skill in phase C. You have many phase C. In each phase C, you must have a skill. Some skill important to determine the information content of a database. Hard skill important to determine an efficient implementation. Now I go to the features of case tools. I discussed with you about diagramming, documentation, analysis, and prototyping. In diagramming, we have a basic function of any case tool. And if you has a lot of predefined shape and behavior in the case tool for data modeling. And in documentation, you have a data dictionary, the supplement diagram tool, and version support to track other changes over time. Analysis, automatic reasoning function. Like forward engineering, you can convert ERD to table design. And reverse engineering, convert table design to ERD. About normalization, later in the chapter 7, we could discuss about how to normalize a table relation in the database, and so forth. And prototyping, we have a wizard to help construct application, and you create initial database design select from a library of design. Now let me go to classification of case tools. You have front end versus back end. Front end case tool can help designer diagram, analyze, and document modules used in the database development process. And back end case tool create prototype and generate code that can be used to cross-check a database with other components of an information system. And this session discusses the function of case tool in more detail and demonstrate a commercial case tool like Visual Professional. And here is a commercial case tool. We can have Power Design 10, Oracle Designer 10 sheet, Visio.net Enterprise Architecture, ER Data Modeler, ER Studio, and Visual Analyst. And you see a lot of tools can help you to support you for database design. Now I go to ER Assistant. Case tool distributed with the textbook. Customized for this textbook, support the ERD notation. You have a drawing tool, diagram checking, easy to use and powerful. They are very easy to use and powerful tool. And now I go to Visual Professional, entry-level version of Visual Studio.net Enterprise Architecture. About drawing tools, about data dictionary support, analysis tool. And in this, we will use a Visual in the lab hour. You have a chance to practice with a Visual Professional tool. Summary. I want to summarize what I discussed with you in chapter 2. The first one is relationship to information system development. You see about the system development is brown or ghost, and we have many phases in development. And I show you about the case tool feature.
Thank you for your learning.